Get them!
When it says justified, does it mean like just say what you're doing?
Wait, not the only one.
Tell me the property or whatever definition you are using to do that step. I will tell you, to get from here to the final answer, there should be 3 steps, 3 properties. You did 2 nearly identical to this in your assignment, in addition to our examples from last time. Open notes, open resource, closed mouths. I want to know what you know, not your neighbor. Okay, let's see if we can get this right. Thomas, Levi, Haven, Heath, Booger, Dylan, so no thunk thunk. Still no Savannah. Wait. God damn. Okay. Savannah's over there. All right. That. Okay. Ashton. Jocelyn. Okay. I would. Okay. Novea, Abby, Jesse, Trey, Killian, Dominic, Isaiah, Grace, Cohen, Elena, Keeley, Sailor, Tyson, Natalie, Abby, Sophia, Jacob. Cool. All right. Should be fairly quick. Is anyone still rolling? All right. No funk. The thing about fidgeting is you need to learn to do it discreetly or else people get annoyed and throw things at you. Okay. Round one. Ahem. Turtle, giraffe, turtle. Right now, you got a turtle humping that giraffe's leg. Nothing's going to happen. Fun to watch, but nothing's going to happen here. So, what do we do? Yeah? Commutative property of multiplication allows me to say that's now 7 times 4f. Yes, you are correct. That is the first step. Okay, now it's turtle, giraffe. But that turtle's still liking that giraffe. We need to pry him off. What now?
Associative.
The associative property says it doesn't matter who you associate with. Grouping doesn't matter. I'm going to put the 9 and the 7 together times 4f. And finally, I'm just going to simplify. That is a, you could either say just multiply, or you could say simplify. Simp for math, right? 63 by 4f. Okay, now both of them go back. This isn't 100% done. I said there would be 3 steps with properties. This multiply / simplify applies to both that, and I can almost do it again. I can now say 63 by 4 is how much?
252.
So, did we get there? Did you say commutative and show it? Did you say associative and show it? After that, if you just multiplied straight through, or maybe you switch the, that is a thing you could do. Did anyone from here do this?
Yeah.
Did anyone do that? And still called it associative?
Yep.
Okay, cool. Either one of those, I'll take that. So then we'll just move our little, no, not you, you. Okay. Either one. You had to use the commutative property to put all the turtles together, and then the associative property to group the turtles together. Oh, there's 3 turtles up there. Little mathematical menage a trois going on. And then you actually multiplied them all together to get to the final answer, whether you did that in a stage or not. Okay? There is x out of 5. Make sure you mark it. Like always, please make sure that you are stating 1.4 properties. You have the work to back it up. You have your score circled or boxed. Okay? So that I know this is the one you did, this is your score. I don't want to hunt for it. Because on Monday, you will take your first review and quiz. Okay, you're going to turn all of this stuff in when you do your quiz on Monday. Right? Monday? So we did 1, 2, 3, 4, 5, and 6 is odd day. Yeah. Monday will be our first review and quiz. All right. Is that you guys? That is you guys, but we're past that. Homework! No, not the creepy lobster. We did properties. We're back to... Okay. Homework. Talk to me. Anything? I had one person come in for questions. That's it. Is everyone able to find the solutions? Okay. Who is actually using the solutions? The cheese stands alone. Remember, there we go. The cheese has a friend. Okay, the idea is solutions are there not so you just copy it down and make it look like you did your homework, Micah. The point is, as you're working, how many times have you looked at someone else's work, whether it was a teacher's, a friend's, someone, you look at their stuff and be like, oh, okay, and the light bulb just goes on. That's why the solutions are there. It's not so you can copy and pretend like you did it. Reality is going to kick you swift in the tender parts if you think that you're just going to copy things down and everything's going to work out. Okay? But if you're using it to make sure you're doing things right and then ask a question when it's still not making sense, that's exactly what I want to see. So, all right, if we got no questions, we're going to end it really easy, I hope. But today is one of the few days that I will ever say this. Ladies and gents, if you have a calculator, put it away. Dun 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 dun. It's really easy. We're just going to go through integers, if you remember how they work. Okay. I'm talking about the negatives below them. Okay. We're going to rip through these real quick. Honestly, I just want to talk about it real quick, and if you guys are good, then I don't know that I'll even assign anything. I think we might just have a day to chill. Okay? All right? If you can behave and not annoy me. So, I do at least want to go through the notes so we can talk about why this works. You all remember on number line. Okay. If I say 3 plus 5, we all know which side are the bigger numbers on, left or right?
Right.
Bigger numbers are always to the right. So when I say 3 plus 5, it's nice and easy. I'm going to add 1, 2, 3, 4, 5. Yay! What is 5 things after that? I'm pretty sure we all know how to count on fingers and toes because that's Alabama math. Well, if it's Arkansas math, then it's fingers and toes, and you can count up to 21. But I'm going to add a 5 to a thing and get to 8. But if I'm at 3 and I say to add a negative 5, you all know that's not just negative 5. What's another word for it? I mean, yeah, I'm not a fan of it. Starts with an O. Octopus. Yes, we will now add the octopus 5. How about opposite? Okay. If I'm going to add a negative 5, I'm just adding in the other direction. Okay, so now we're going 1, 2, 3, 4, 5. But what happens when I hit 2 and then 1 and then 0? Now what? Same thing, but you count the other direction. Please tell me that you remember how to do addition of basic integers.
I can.
It's a 3. It just got kind of like head chopped off. Okay. Y'all know the whole like chicken with its head cut off thing? That actually does happen.
Yeah.
Yeah,
And there they go. So if I say a negative 3 plus 5, I'm still doing the same thing. 1, 2, 3, 4, 5. But now where does it end up? Positive 2. I want you to pay attention to the difference between those. Shut your noise hole right now. Thank you. You notice the difference between 3 plus a negative 5 and negative 3 plus positive 5. I still went from A3 to A2. That's because the distance between them is 5 units. That's called absolute value. We're going to talk about it a little more later this semester, but do you all remember hearing absolute value?
Yeah.
Absolute value, now I know this might be jumping the gun a little bit, absolute value of 5 is 5. The absolute value of negative 5 is
5.
also 5. Because it's the distance from 0, and distance can't be negative. How many times were you working before, like, find the length of this triangle, and you end up with a negative number? You know that's not possible. Because you can't have a negative number, right? You have to have positive numbers. Example, it is, talking about the commutative thing, right? 11 miles from my house to the school. Does that mean it's negative 11 miles from the school to my house? No! 11 is 11 no matter what. Okay, who in here, who's the, Heath, how tall are you, bud? No, you're like as tall as me. Aren't you? No? Okay. Okay. Yeah, get over here. Like I'm 5'11". This is okay. Maybe my estimation is incorrect.
Not really.
He's like a solid 0 taller,
Yeah,
yeah.
but look at the bottom of his shoes. That?
Yeah.
I got old fart shoes on. I got like Grandpa New Balance here. Okay, so like 5'8". All right. I was wrong. Okay, so if Heath is 5'8", standing right now from the ground up, does that mean if I take Heath and stick him to the ceiling like he's hanging from a cave on Hoth, and the Wampa's going to come eat him? Watch Star Wars. For crap's sake, that movie's been out for 40 years already. Okay, then does that mean he's now negative 5'8"? Because he's going the other direction? You cannot say that someone is a negative height. Okay? I can't say that Killian's negative 4 feet tall unless I'm just trying to insult her. You just can't. Distances and lengths can't be negative. So I just want to point out that I went from a 2 to a 3, a 2 to a 3, because no matter what, it was still 5 units of distance. It's just the sign is going to change depending on which direction we're going. If I take a negative 3 plus a negative 5, okay, Dawson, dude, can I borrow $5?
Yeah. What about negative $5?
Well, yeah, if I borrow if I $5. There were other words in there. Okay, y'all, it's been a long day, but just we're gonna edit that part out. If I borrow $5, if I borrow $5, there we go, $5. If I borrow $5, that's my money is now negative 5, right? So if I then come and who's Natalie, right? I borrow $3 from you. Now how much do I owe?
-2.
No. I borrowed $5. I borrowed $3. I now owe $8. So right next to this, maybe we should write something like a negative plus a negative is more negative. A negative plus a negative is more negative. And that's where you start getting into debit and credit in personal finance. Who in here has their own debit card? Okay, do you know what a debit is? No. A debit is where I take away. A credit is where I add. So a debit card is where I take money directly from my account. A credit card is where I add money to the balance I owe.
It's like the same thing, right?
Now, I'm still going to have to pay it back, but one of them is I'm taking money from the account. The other is I'm adding money to the account. It's just this one represents how much money I have. This one represents how much money I have to pay back. So you could consider it as this is adding, this is subtracting where this is truly adding a negative. You start getting into this cross-curricular business with personal finance. Okay, so let's write some rules at least with this. Off to the side, oh yeah, there's rules. What if I take a positive plus a positive? More positive. If I take a negative plus a negative.
I get more negative.
Okay, but here's the problem. If I have a negative plus a positive, or a positive plus a negative, what's it going to be? Well, it depends. What if I took a negative 5 plus 2 versus a negative 2 plus 5?
That's just like the same difference.
Oh, no, it isn't. You owe me $5. You give me $2 back. Don't you still owe me $3? You owe me $2. You give me 5. Don't I now have an extra $3? This is a negative 3 where this is a positive 3. How do I say this then? How do I make a rule for when I add positives and negatives together?
It depends.
It'd be about like a fight in middle school. Depends who's bigger. That kid who hit their growth spurt a year and a half early and is a foot taller than the other one, well, that's probably a foregone conclusion. Okay? Back years ago, when I coached middle school football, I had 7th and 8th grade teams. Y'all, you can tell which kids hit puberty way too early. Because when you got the kid who's like 180 pounds and already rocking a six-pack up against the kid who's like 92 pounds and still talks like this. Like, that's not safe.
No.
That kid is going to destroy the other one. Okay? It depends who was bigger. If I take a negative and a positive or a positive and a negative, the sign on the answer depends which one had more weight to begin with. Look over here, 5 and 2, who's bigger? Don't even look at the signs. Don't look at the signs. Who's bigger, 5 or 2? 5. Is 5 negative or positive?
Negative.
So the answer is negative. Look at these ones. 5 and 2. Who's bigger? 5 is positive. So the answer is positive. Okay? Who's bigger? I want you to write those down. Those are nowhere in a book. Those are not in our book. Okay? Please have those written down. So if you would, down at the bottom there, show it on a number line. I know the number line's kind of overkill, but I still want you to show it so I at least know that you understand where these numbers go. If you ever get stuck on these, think of it in terms of money. Kids understand money. -8. I owe you $8. +4. I gave you $4. Now where am I at? Okay. Booker Jr. And be careful up there too. We learned last time Lena's gonna put you in her freezer or something. Never know. It's a negative and a positive. Who's bigger? Who's bigger? Got more weight? The 8. So I know that my answer is going to be negative because the negative numbers got more weight to it. Now, what is 8 minus 4 normally? 4. So it's a -4. If you need to think about it in terms of money, just visualize. Yo, bud, I owe you $8. I just gave you $4. How much do I still owe you?
According to Natalie, it's only $4.
Okay. I owe you $4. -4. Okay? So, a little bit of foreshadowing. Absolute value. Absolute value. I want you to write up there. Oh, no, it's got it. It's got it. Highlight it. Big neon flashing sign, like the exclamation point right above the dude's head says side quest over here. Absolute value is distance from 0. So when I say the absolute value of 38, how far away from 0 is 38? If I say the absolute value of -67, positive or negative? Positive, because distance is always positive. Okay? You look down here, adding numbers with the same sign, adding numbers with a different sign. They talk out exactly what I put up there. We put ours in just nice little symbols. They got theirs in a lot of words. It says, if you're adding the same sign, they're going to keep that sign. If they're adding different signs, they say you subtract the absolute value. The way you can say that is, I will always take big minus small. It's their absolute values. That's what we were doing before when we said who's got more weight. It's their absolute value, their distance from 0. Who's bigger? Okay? And then you just keep the sign of the bigger one. Okay? Said that, oh man, when you did Oklahoma drills, like tackling dummies, Kid pops up, fight. Okay? You know what happened when you had that kid who was 180 and already had the six-pack versus that little dude who was like 90 pounds? It was murder. Okay? You go with who's bigger. And it was a pair of twins, too. There were two dudes who were both like that, and they're on our 8th grade team. It was fun to watch them play. It was unsafe, but it was fun to watch them play. Okay. I have negative 12 plus 7. It's a negative and a positive. So you go with who's bigger. What's my sign going to be? It's going to be negative because the 12's got more weight to it. And then just take 12 minus 7. Because that tells you how far their absolute values are apart. Count it out with fingers if you need to. 12, 11, 10, 9, 8, 7. Use fingers. Y'all, I'm the math teacher. Last time I got tested, my IQ was 138. I still count on my fingers. Okay? I count on my fingers. Use your fingers. I see a negative 5. Next up, I have a negative plus another negative. More negative, right? Further in debt. Late night online shopping. So, now you add together their absolute values. If you owe me $18 and then you owe another $2, you owe me $20. Okay, now they're not integers, but the rules still apply. It's a negative added to a positive. Who's bigger? So I know my answer is going to be positive. Now, take 9.5 minus 4.8. Oh no, he took away the calculators. We're going to have to go old school. 9.5 minus 4.8. I can't take an 8 away from a 5. 15 minus 8. 8 minus 4. Was it positive or negative? Okay. Fractions. You all used to be so good at fractions. Oh, yes, you were. Because you did fractions 3rd through 6th grade. And then they started letting you use a calculator. And you took all that knowledge and went, yeet. Gone. I no longer remember fractions. So here's what we're going to do. A little bit of walk down memory lane here. Oh, here we go. Who up here can't cut a pizza to save their life? Like you know if you're cutting the pizza, mom and dad making fun of you. It's like, okay, or they just won't let you. My wife stopped actually holding the pizza cutter. She just sets it on the counter and walks away and says, "You do it." Now I feel kind of bad. Well, she makes me do it because I used to mock her. Like her pizzas were like. they were kind of rough. So, if I had something broken into 6ths and into 4ths, can I say that one slice of this is equal to one slice of that? No, they're not the same. Okay? It's not the same proportion. So, I need to make them the same. Means you got to cut them up more. I need to overlap on top of this one 6th. That was really bad. 6th. There we go, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And, oh, God, this is bad. Okay. 1, 2, 3, 4. Man, okay, my pizza sucks, all right? I'm no better. You need to cut them into the same size, right? So you can actually compare them. What is the smallest number that both 4 and 6 go into?
12.
Do you remember what that's called? Vocabulary. Where's my vocabulary at?
Greatest common denominator.
Ooh, close. Not greatest.
Least common denominator.
Least common denominator. I need to say, I can't have fourths and sixths. I need both in twelfths. How do I turn a 4 into a 12? You remember this? Times 3 times 3. Why do I multiply both?
Because what you do to the bottom, you have to do to the top. And that's about how
Okay, I'm hearing
That's all we got.
what you do to the bottom, you do to the top. Okay, that was probably drilled into your brain. I'm hearing they both need attention. Fair. Okay. Remind me, what is 3 divided by 3?
1.
What's anything times 1? Itself. So when I take 3/4 times 3 over 3, look at what I'm really multiplying by. I'm taking it times 1. It's just a really bad one. Okay. I'm taking 3/4 times 1. 3/4 times 1 is still 3/4. But I'm giving it a little bit of a makeover. Giving it a nice suit. Okay, looks good now. Now this is a 9/12 plus. How do I turn 6 into 12? Times 2 times 2. So now this is plus a negative 10/12. See how now they're both out of 12. A pizza cut into 12 slices, a pizza cut into 12 slices. What's better, having 10 pieces or 9 pieces?
10.
Right? Because now they're all worth the same. So a positive plus a negative, who's got more weight? The negative has more weight now. So I know my answer is going to be negative. And if you have 9 waffles plus negative 10 waffles, you owe me a waffle. 9/12 plus negative 10/12 is negative 1/12. Okay. The whole, okay. You can either call it a negative 1 over 12, or you can say a negative 1/12. Because this one says negative 1 divided by 12. Well, that will be a negative 1/12. Nope. I was going to say, you have your calculator, try it, but I told you to put those away. So I'm going to bring this up. Okay. If I take a 1 divided by a 12, I get thing. Okay. Now think about this. If I had, do the lame calculators have a negative? Yeah, they do. Okay, if I said 1 negative divided by 12, it says a negative, this ugly decimal. What if I had a negative and then used parentheses? Negative, no. God, I hate these things. Okay, what if I had the negative on the outside? I'm just going to say parentheses 1 divided by 12, and then I'll have the negative 1 on the outside. God, these, never use the calculators on these computers. They're trash. Who's got, who has their own scientific? Just show of hands. You're not relying on your phone for a calculator. You have your own scientific or graphing calculator. Okay. Y'all, you're in high school. You're going to need at the least a scientific calculator. I know for some folks, $10 to get a calculator is actually a big deal. You do not have to pay for that. Come talk to me or the guidance office. We'll get you hooked up if you just can't get one. If you want your own, go get your own that you want. Get familiar with it. Bring it to class every day. Make sure you're good with it. Okay? But either way, either the negative on the numerator or out front. The one thing we don't want to do, though, is have a negative on the denominator. It's considered improper. It'd be like Superman wearing your underwear on the outside. Okay? You're going to have your pants, and then you got your grundies on the outside. And it looks wrong. Okay? So leave the negative on the numerator or out front. So, here we go. It's been a long time. Hey, that's a good song. Down at the bottom, no calculator, no fractions or decimals. Those were just a little bit of review. Okay, get them. Who's bigger? What's the sign going to be? I know it's a review, but if you can't do this stuff without a calculator, we're in for a long haul. Okay. Now, I will let you use a calculator for the rest of time. This is like the one day that I say no. The reason we're not doing it today is because this is a specific skill we should review and remember. If you can't do this stuff without a calculator, by all means, the rest of the year, use a calculator. I want you to have the tool that helps you to focus on the skill we're learning now, not the skill you should have known before. Okay? You'll find that I'm a little bit different than other math teachers in my philosophy on a calculator. Personally, I say, use your resources. Who's really good with their multiplication facts? Like, I did number munchers on the Apple Mac 2, 5.5-inch floppy disk. Like green screen, it looked like a little toaster oven. Okay, that was my computer in second grade. But I tell you what, I wrecked every record on number munchers. You move this little dude around like a bingo square, and you had to eat all the multiples of different.
Oh yeah, I played that.
Right?
We just braid something.
Okay. I'm betting between like 2012 down to 1992. I'm betting there was a difference. But those multiplication facts, who could right now off the top of your head, you just know what 13 by 7 is?
13. Quickly.
I don't know my multiples past 10.
Okay, who is 100% guaranteed I can knock out a 12 by 12? 12 by 9. I just know it.
Good enough.
10 by 10.
What's 100? I don't know what.
No, the whole box.
Oh.
10 by 10 what?
7 by 9.
Yeah.
Okay? You have to know those things. You're in algebra, not in second grade. Okay? So if those are things that you're a little sketchy on, use the calculator. Today, yeah, we're going to go old school, but that's because we're trying to knock some rust off the gears. I have a negative plus a negative. What's the sign going to be?
Negative.
More negative. I have a negative and a positive. What's the sign going to be? How do I know? Got more weight to it. The absolute value is greater. So I take 11 minus 9 is 2, and because it's got more weight on the negative side, negative 2. Do the same thing. Oh, wait. Isn't that literally the same thing?
Yes.
What did they change? Commutative property of addition. It works for integers. Still negative 2. And a negative is more negative. Okay? Just got to make sure. Got to make sure. Inverse property of addition. Isaiah, you've been gone for a while. Here, I'm gonna give you 4 donuts. Or four muffins.
Okay.
Pretty cool, right?
Yeah.
Okay, I'm also gonna take away 4 muffins.
Oh.
What does Isaiah have now?
No muffins.
No muffins.
Depression.
That is called the additive inverse. The additive inverse, or inverse property of addition, says if I add the opposite of a thing, they cancel. Okay? Yeah. I think on Monday we're going to have a seating chart. Subtracting numbers, you all know you don't actually subtract a thing. What do you really do? Add the opposite, whatever it is. So I'm either adding a, well, negative, or I'm subtracting, and positive is also adding a negative thing. Always add the opposite. Words. Words are hard. I'm tired. Come on down here. If I see -8 minus a -13, you don't actually subtract a -13. You, please tell me you remember doing that. Okay? Add the opposite. Literally, write it on the paper. Add the opposite. And then, well, who's bigger? So I know my answer is going to be positive, and you subtract their absolute values to find out how much bigger is it. 13 is bigger than 8 by how much? 5. And I know my answer will be positive because 13 had more weight to it. 3.5 minus 12.4. I don't really subtract 12.4. I add the opposite. Okay.
So, are we never going to use subtraction again?
Okay. It's one of those things where just because it doesn't exist doesn't mean that you can't use it. Look at religion. Okay? People make up deities all the time. They use it to structure their lives and create a system of worth for their life. People have been doing that since the dawn of mankind. Like, I believe this rock gave birth to me. I came from this rock. I believe someone yanked their body parts out and gave it to someone else. I believe that a star fell down from the earth and it sprouted dinosaurs and I grew into one or something. Like, people believe different things. You can use that. Personally, I have all of the envy for someone who has genuine faith. Like, not I was indoctrinated, I do this because I was told, but I believe this. This is a core tenet of my personality. I have so much envy for those people. Okay? Because it gives meaning. Can I still use subtraction even though I know it's not a provable algebraic structure? Yeah? What's 16 minus 5? Did you have to stop and say, no, I will now add -5? No, you went back to 16, right? Did I say 11 or 5? I don't know, whatever number, right? You're not just going to stop and redo your entire thought process. I'm saying mathematically, they are different. That doesn't mean that I can't actually subtract if you want. Can you, off the top of your head, take 3.5 and subtract 12.4? Or do you know that I'm actually adding the opposite? That means I'll take instead 12.4 minus 3.5. But remember that it's going to be negative. Okay? I would much, much rather use whatever works for me. I'm just showing you different ways. 9 minus 9, why that is even written, what's it called? What's it called?
Inverse property.
Inverse property of addition, or additive identity. Well, It's the inverse property of it that creates the identity. Oh, so I'm saying it wrong. Overcomplicating things. All right, cross that out. We're good. Oh no, real numbers and real words. And then Satan said, let there be math and words together. A reef explorer dives 25 feet to photograph brain coral. Y'all ever heard of brain coral?
No.
Neither have I. Rises 16 feet to travel over a ridge before diving a further 47. Then they rise another 29 to a cavern, blah, 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 blah. Write these down in a line. Okay? Reef explorer. No, it's water. Blue. Okay? Stick figure Steve here is going to dive down 25 feet. Then is going to rise 16 feet. Then is going to dive 47 feet, so that's a negative. And then finally is going to come back up 29. That's just a visualization. You can't just write the numbers, right? You understand that diving is a negative and rising is a positive. So, whew, which one, what do I do first? Well, I like that. Here, I was just going to roll along through here and say, well, negative 25 plus 16. I'd get my negative 9. Then I would add it to negative 4. I was going to do that. But then along comes Heath and says, how about I group the negatives together? Can you do that? Because it's not subtraction. Subtraction isn't commutative, but addition is. I can now regroup this and say that's a negative 25 plus a negative 47 plus a 16 plus 29. Oh, more parentheses. There you go. So, you owe me $25. I'm stupid enough to let you borrow another 47. How much do you owe me? You sure?
72. Negative 72.
There we go. Negative 72. Y'all, you can just go old school here, 25 plus 47. But I know it's going to be negative because they're both negative. Plus 16 plus 29. Compatible number parts. Take 16 plus 29.
45.
Okay? So now when I go smacking those together, because I have all of my negatives in one basket and all of my positives in another basket, we now have, who's bigger?
Negative.
So I know my answer is going to be negative, which makes sense. He didn't come flopping out of the water like a dolphin. He's still under the water. And then, how much? Take 72 minus 45. Because you subtract their absolute values. And I say 12 minus 5 is 7, 6 minus 4 is 2. And I know my answer is going to be negative. Okay? Now, if you can mental mojo, great. In the future, are you going to use a calculator? Yup. Can you do it right now? Can you write out thing plus thing plus thing plus thing, or however many there are? Can you find it? Right now. Write out the problem first. These got a little bit bigger numbers on it. You might have to go old school and write everything out. Tell me the numbers. A submarine dives 803 feet. What's the number? Negative 803. They rise to 15. So positive or negative? They dive, negative 2619. And finally, rise another 734. It's your choice if you just want to go left to right, or if you want to use that commutative property like Heath did and rearrange them. It's your choice. Keep in mind, when we get to your daily or your weekly quiz on Monday, you are turning in your notes. Everything that we have written up here should be in your notes. All of it. If it's missing, that is effectively you ain't doing what you're supposed to in class. And it is reflected as such. Okay? You also get to use every bit of this on your quiz. So maybe it'd be a good idea to have all this stuff written down. All these little notes. Every time I say, hey, highlight this, put a big sign next to this, tell yourself this, tell yourself that. You get to use it all. How many of you grouped the negatives together? About 2/3 of you. Who just went left to right? Just went for it? No one? Okay. So if I take the negative 803 and the negative 2619 and smack those together, I have a negative 2, 1, 2, 8, 6, 4, 1, 3, 34, 22, plus take the positive one, 734, and a 215, put those together, 949. If I have to ask which one's bigger, we're probably in trouble. Okay. I subtract between them to find out how far apart they are, and I just know that my answer is going to be negative. 3422 minus 949. Going to be doing a bit of that borrowing. Call it 12. Call it 11. Call it 13. 2473. Okay. Now you may take your calculators out. I would like everyone to please make sure you can find the difference between your negative button and your subtract button. They are different. They do different things.
I thought subtraction did this.
Do you know that the subtraction button on a calculator literally adds a negative? That's how it's programmed. Because to write the programming language for it, they have to have a structure for it. They have to have code to confine what it's doing. And one of them is subtraction doesn't exist, add a negative. All built into the little ones and zeros in that calculator. Everyone sees their negative and their minus. Okay? Everyone's got to have the negative and the minus. You got to know where they are. If you don't, you're going to be hurting. Oh, all right. There's a black and white graphing calculator that's almost the same, but it does all the cool stuff that these bumblebees will. Nah, those got put in timeout.
All of them?
Yeah. Well, those two. Yeah, because them. So I'm going to come all the way back here. Oh, bummer. Can you do this the right way? Type it. Come on, Frank. Come on, Frank. Let's go, Frank. There we go. Oh, come on, Frank, you cross-eyed redneck son. Okay. Now, said, you have to know how your own calculator works. I want you to see what happens when I type this exactly as it's written. If I take a negative 803 plus 215 plus negative 2619 plus 734. If I type it exactly as written on this particular calculator, because I have the negative button, everything comes out fine. I'm going to come back here, I'll highlight, and change some stuff. What if I use the minus button instead? See how it physically changes it from little one to big one? About 2/3 of the way up to halfway in the middle. What this is now saying is plus and minus. I want you to add and simultaneously add the negative of this number. So if I say, go ahead and do that, it's going to say, what? For anyone who is using the bumblebees in class or has their own graphing calculator, you know what? Even some of the scientific calculators, okay, these ones. If you have a scientific calculator and you type something dumb, it's going to say syntax. Syntax, besides being a type of explosive, and that's kind of fun, syntax is the order in which you say things. Yoda had weird syntax. Yoda did not say bad English. Yoda just said it out of order. His syntax was wrong. If you ever see it say syntax, it's asking, why'd you type it like that? Okay? That's all it is. If you ever see that error, it's saying you typed something goofy. And I bet the negative sign to the minus sign is your problem. If you're using the graphing calculators, check this out, go to. If I say go to the thing, it will literally go to the thing and highlight, this is where you screwed up. Oh, okay, change that to a negative. Okay, so I just want to make sure that everyone knows how those work. Okay, most scientific calculators, the lame calculator on the laptop, I hate it. Everyone hold up whatever your calculator is. I want to see if anyone's got the really, really bad, like, get it in a box of Lucky Charms kind of bad. All right. It'll work, but you have to know how to use it. You're going to have to, does it have it with parentheses at least? If you don't even see parentheses, we're probably going to want to upgrade, okay? Jesse, show me that one again. That one has parentheses, but it won't show them in line, will it? Do you see parenthesis button? Okay, cool. So that's like the one that I'd been using since 6th grade, where you can press the parentheses, and up in the top corner, in itty bitty little print, it'll have parentheses showing you, hey, you have parentheses, and they're in play. But you have to remember where they are. Okay? So beyond those two, everyone else in here, you all have what's called a right view calculator. That means you can type it exactly as it's written. I can give you the biggest, nastiest fraction up here, full of all kinds of stuff, and you can type it exactly like that, hit enter, and it'll do it for you. Okay? So, on to multiply and divide. I don't know that I'm going to bother with this at all. Ladies and gents, what is positive times positive? Positive times negative. Negative times negative. Positive. And a negative times a positive.
Depends on which number is bigger. To negative. A positive? Negative?
If I multiply two things with different signs, it is always negative. If they're the same sign, they're always positive.
Okay.
Put right next to it if you have to. Positive times positive. Positive times negative. Negative times positive. Negative times negative. Are positive, negative, negative, positive. If you have to write it down, write it down. That's it. That's how multiplying and dividing goes. Now, I said multiply in between all of those. Same rule for divide. Because division doesn't exist. Division is just multiplication by a reciprocal. Okay? So if I say divide by 3, I'm really multiplying by 1/3. If I say divide by negative 1/2, I'm really multiplying by a negative 2. The reciprocal, flip. Okay? I don't think that I really need to do anything with that. Y'all know how to press buttons on a calculator. Maybe let's come back here and say, do you remember how fractions work? How do I multiply fractions?
Straight across.
Straight across, and you don't even need any common denominators. Straight across, 3 by 1 is 3, 4 by 2 is 8, negative times positive is a negative. Okay? What happens when we talked about those exponents. What does that mean? Negative 4 squared. Itself, right? A negative 4 with another negative 4. So what happens if I take negative 4 and square it?
Must be a positive.
It's a positive 4. Everyone got that calculator on hand?
Yes. I got one of those.
Okay. If negative 4 times negative 4 is positive 16, then tell me why. Ain't nothing but a heartbreak. No, I lived through that. Don't you dare. What happened? Why is negative 4 to the second coming out as a negative 16 on my calculator then?
I think that isn't that what it.
Because you do the same thing when it's positive, but you change it to a negative.
Because the calculator is changing the answer to a negative because I don't have parentheses on there. This, the calculator does the order of operations. It reads this as negative 1 times 4 squared because you're supposed to do exponents before multiplication. But if I wanted to make sure it was a negative 4, I need to have parentheses around it. The difference between them is when I do parenthesis negative 4 and square it, this is negative 1 times 4 squared. This is negative 1 times 4 squared. Y'all know how that nonverbal communication works. If I put a pause in a different place, it means something. If I say, Ashton, what are you doing?
Saying, listening to you.
What did the tone say? What did the pause say? Okay. That long of a pause in between usually means you're marshaling thoughts, trying to say it a certain way, probably because, and then the tone says disappointment. But if I say, Ashton, what are you doing? The pause, I'm trying not to swear. And then the emphasis on are, like this particular activity. What are you doing? Why this? The nonverbal communication there, we do all the time. In terms of math, there's a difference between negative 4 squared and negative 4 squared. Do you hear how the pause in what I'm saying kind of tosses parentheses on it and groups the things together in my speech? So if you say it a certain way, you type it a certain way. I want you to put something on your paper, maybe right here, just in big letters, parentheses. Parentheses are such a huge deal. If you do not use parentheses, you will screw up negatives for the rest of your life. Okay? I guarantee it. Parentheses. With an I at the end, it's a singular. Parenthesis versus parentheses. Singular and plural. Okay? Please use parentheses when you're inputting things into a calculator and when you're writing them on your paper. I don't think we need to do the rest. We know how to press buttons. If you don't know how to fraction by now, you're kind of hosed. Down here, we already talked about simplifying radicals, particularly square roots. Each one of these is going to have a sign in front of it. It's called a principal root. Principal root says, don't worry about the adding in a plus minus every time you do a square root. If the square root's already there, work with what's there. If you put the square root there as part of solving, then we have to think about plus or minus. So if this already has a negative in front of it, am I allowed to take the square root of 25? Y'all got a calculator. Can I take the square root of 25? Or does it say error, you broke math?
Error.
Yes, I can. What is the square root of 25? 5. The negative is in front of the radical, so it's a negative 5. Try to do instead the square root of negative 25. Okay, it doesn't exist because there is no number times itself that makes a negative, because any sign times itself is always a positive. Come back to Algebra 2. We'll tell you all about imaginary numbers. What these mean is, if there's a sign in front of the radical, just keep the sign. If it says plus or minus this thing, my answer is going to be a plus or a minus. Do you remember from the other day, what do I do with the radical of thing over thing?
You would do the radicals of both of them and then still.
Square root both. What's the square root of 4?
Negative
Square root of 49.
Ooh, that's good.
7.
7.
Know your squares. Just like most of you said, I got my multiplication facts in that 10 by 10 box. Know your squares through 20. Cubes through 10, fourths through 5, as many powers of 2 and 3 as you can get your hands on. For Algebra 1, I would say at the least, you should all know your first 10 squares, right? Because 7 squared is just 7 times 7. Y'all seen the multiplication charts with, like, it's 1, 2, 3, and it's all filled in with all the numbers? So you finger track it, right? Like column with row, it makes this. All right, those, if you go on the diagonal of it, it's always your squares because it's 4 times 4. So the diagonal is always your squares. That's why if you have one of those on hand, I would just highlight the diagonal so you always have your squares on hand. Comes in handy. Handy. Neener. Down at the bottom, those 4. If you don't know what those perfect squares are off the top of your head, then start using the calculator. I'd like you to find all of those and remember that you keep the sign with it. Every one of those is a perfect square.
So,
What times itself makes this number?
did you explain the plus minus thing?
It always keeps the sign. Whatever sign is there is the sign that goes with your answer.
Yeah, but what is the sign? Like, what is the plus and then the minus under?
A positive is a positive, a negative is a negative. A plus minus denotes both. This is a positive 2/7 and a negative 2/7. So instead of having to write them out, no, this is shorthand for 2/7 and negative 2/7. It's just shorthand for both. Okay? And because having both the positive and negative answer happens so often in math, they give it its own symbol. These should be quick. We should have 8, a plus or minus 4, a negative 11, and a plus or minus 1/6. Do not call it 0.183 blah, 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 whatever it is. Okay? Don't go to decimal town. Square root of 1 over square root of 36. All right, divide things. I'm pretty sure you all know how to divide numbers. Multiplicative inverse. Anything times its inverse is always 1. Like, what's half of 2? 1. What's 3 times a third? Right? Here's what's 4 times a quarter?
1.
Right? 4 quarters makes 1. Whenever I have something times its inverse, y'all remember cross-canceling? Okay? So you get 1 over 1. I hope we remember all that. All right. Yeehaw! Both. Top and bottom. Show me that you remember how fractions work. I dare you to do it without a calculator.
I don't take that dare.
And by dare you, meaning if you're in high school, you should know how to do this.
I'm in high school.
Okay. Try it without the calculator. See if you remember the rules. Talk to your neighbor. Argue about the rules. Dividing by fractions is easy as pie. Flip the second and multiply. You're fired.
So that means I can go home. You want to just do A through D?
I want you to do the whole lot of it. What do you mean A through D? That's multiple choice, bud. Answer the question, and one of those things is its answer.
Do we do this second part then?
Yeah.
Okay. Oh, what's
What is the value of x over y? Oh, wait.
Hold on, let me see what we got here. Oh, yeah, this is the last one. Cool. Perfect.
I don't know.
Perfect, perfect, perfect.
Because I just like, you know, when like the what was it called again? When two negatives equal positive
When you multiply or divide, same rules.
Okay.
Yep. X over Y, they tell us X. Negative 3/4. Y, they tell us negative 2/3. Dividing a fraction, easy as pie. Flip the second and multiply. I don't really divide. I multiply by a reciprocal. I don't really divide by a fraction. I multiply by its reciprocal. Do you remember cross-canceling? Can I reduce anything that 3 and 4 have in common? Can I reduce anything that 3 and 2 have in common? Can I reduce this way? Okay. You check all 4. Can I reduce this way? Can I reduce this way? Can I reduce this way? And then you get, like some WWF stuff. Okay. So negative 3/4 times a negative 3/2 is a positive, negative by negative, 9/8. Okay. Downstairs, when we say, what is the value of 3/4 divided by negative 5/2? I'm going to turn that into 3/4. What? Not divided by negative 5/2. Dividing by fractions is easy as pie.
Times negative 2/5.
Flip the second and multiply. Is there anything that I'm able to cross-cancel or cancel within a fraction here? Yeah, there is. Because 2 and 4 are both divisible by what?
2.
2. 2 divided by 2 is 1. 4 divided by 2 is 2. Now that I have reduced as much as I can, I'll go across and say 3 by 1 is 3. Go across, say 2 by 5 is 10. And positive times negative is negative.
Because the signs are different.
Okay. Okay. Why is this on my floor?
Because of asked you.
I will have an assignment. It is not going to be long.
Oh, thank you.
I am going to ask. Hey! You quiet now. You listen. I'm going to give you an assignment. I am asking that you try to be honest with yourself. Don't use a calculator on it. The rest of the year, I'm letting you use a calculator on everything. I would like you to use a calculator to check your work. Don't use it to do the work. Okay?